Mathematics is made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydale online class. So today we want to look at the sine rule. The sine rule. Okay? The sine rule. Of course, we use the sine rule to solve. We actually use the sine rule to solve triangles. There are so many types of triangle. We have the scaly triangle, equilateral triangle, isosceles triangle, right angle triangles. So in case of right angle triangle, we are on the safer side. We know what to do. We can actually use Pythagoras theorem, or we use SOHCAHTOA to solve that. You can check my videos. I have videos on SOHCAHTOA. I have videos on trig. I have about 6 or 7 videos on trig. But what if the triangle is a scaly triangle? The importance of this sine rule and cosine rule is that you can actually use it to solve any type of triangle, even if it is right angle triangle. So that is one of the importance of this sine rule. So we are used to SOHCAHTOA when it's right angle triangle, when it is right angle triangle. That is when we have something like of this nature. If one of the angle in a triangle is perpendicular, is 90 degrees, then we can actually apply Pythagoras theorem on SOHCAHTOA on this. But what if we have a obtuse triangle of this nature? They have something like this, that the angle here is around 150. So how do we solve? How do we find out if you are given one side and all the three sides? How do we do that? Or if you are given 3 sides and we don't know any angle, so how do we resolve such triangles? That's what we are talking about. So we actually know we actually know what to do when we have right angle triangle. So, but before I will introduce this SOHCAHTOA, I will try and do a recap, a kind of recap on quadrants before we go into sine rule properly. Quadrants, we do a kind of recap on quadrants. You know, you have 0, 90 degrees, 180, 270, back to 360 degrees. Okay. So it now depends on the convention that we decide to approach. We know we have cast. So if you move anti-clockwise, it is called cast. But if you move clockwise, it is called arcs. What is the implication of all this? In this case now, it shows that both sine, cosine are tangent of this angle between 0 and 90. They are all positive here. Between 0 and 90, sine of that angle is sine of an angle is positive, cosine is positive, and the tangent is also positive. But between 90 and 180 degrees, what will happen? Between 90 and 180 degrees, where we have 180 degrees minus theta, is only sine that is possible within this range. Okay? Cosine and tangent will be negative between 90 and 180. Between 180 and 270 degrees, it can be 270 degrees minus theta, depending on the textbook, or some textbook will say theta plus 180 degrees, irrespective of how we have it. It is only tangent that is positive here. Tangent of an angle between 180 and 270, that is positive. Both sine and cosine will be negative at this quadrant. Then the last quadrant, where we have 360 degrees minus theta, the fourth quadrant, it is only cosine that is positive. Sine and tangent will be negative here. This is first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. So we should note that between 0 and 90 degrees, sine of an angle, cosine and tangent of an angle is positive. Between 90 to 180 is only sine of that angle that is positive. Cosine and tangent, they're actually negative. At the third quadrant, only tan is positive. Then at the last quadrant, it's only cos that is positive. So we are going to see the effects or the implication. So that simply means that under sine rule, sine of an angle now, if you have sine 120 will have the same value as sine 60. Same value, you can check, positive. But if you have cos 120, it's going to be negative cos 60. That's the implication. So the knowledge of quadrants is actually needed under sine rule. Then when do we apply sine rule to solve a triangle? when do we apply sine rule? There are conditions because we have sine rule and we have cosine rule. When do we apply sine rule? The first is that when to apply sine rule. So we use sine rule to solve triangle in which either two angles and any given sides are given. That is, when we have two angles and any sides, we apply sine rule when we have to a triangle in which either two angles and one side are given. Two angles and one side are given, or two sides and the opposite, the two sides and the angle opposite one of them are given. Or when we have two sides and when we have two sides and angle opposite one of them are given, we can actually go ahead and apply sine rule, because there are conditions to apply the sine rule. You know, we have sine rule and cosine rule. So if you want to apply sine rule, you can only apply it when two sides are given and one side. When we can apply this either when we have two sides, two angles, when we have two angles and any side, or when we have two sides and angle opposite to one of these two sides. Excuse me. That's the condition to use sine rule. Okay, this is the condition to use sine rule. Then the sine rule we are talking about, what is the formula for the sine rule? So this is the formula for sine rule. We have A all over sine A is equal to B all over sine B, and it's equal to what? C all over sine C. Okay, that is this what we are talking about. If you have a triangle A, B, C, the side that faces this angle A, it is denoted as small a. The one that faces angle B is denoted as small b. Then C is denoted as small c. So how do we apply sine rule? This side A here, all over the sine of angle A will be equal to B all over the sine of angle B, which is equal to C all over the sine of angle C. So if A over sine A is equal to B over sine B and is equal to C over sine C, then we can equate two at a time. So we can actually equate two at a time. You can say A over sine A, then it's equal to B over sine B, or you say B over sine B, you equate to C over sine C. So that is what we do. That's the formula for sine rule. A over sine A is equal to B over sine B and is equal to C over sine C. So now I'm going to take two examples under sine rule. Let's take two examples under sine rule. Let's take examples under sine rule. Let's take two examples under sine rule. So let's see this example. So the question says calculate. Example 1. The question says that we should calculate the values of angles A and C of triangle ABC, where B, that is side B, is equal to 14.35 centimeters, A is equal to 7.82 centimeters, and B is equal to 115.6 degrees. Okay, solution. Of course, you sketch a triangle, but in this case now, we have to be very careful because angle B is more than 100. So let me sketch it. I can sketch something of this nature and say something like this. I'll say this is A, B, then I'll say this is C. Of course, it does not matter. Here is 115.6 degrees. It's more than 90. We are given this side is A. Side A is this side B, and this side C. So here we are given side B to be 14.35 centimeters. We are given side A to be 7.82 centimeters. So this is what we are given. So we are asked to calculate angle A and angle C. Look at, in this case now, the first thing that we can do is, we know B, we know side B, and we know angle B. We know side A. Automatically we can actually find angle A. That's the first angle that we are going to get. So once we get angle A, then we just use sum of angle in the triangle to get angle C. And that's what we are going to do. So in this case now, we are given two sides and one angle. And that angle actually opposite one of the sides. That is one of the conditions to use sine rule. We are given two sides and one angle. The angle that will be given must be the angle of one of these two sides. And this one actually satisfies the condition. So what we are going to do now is that if you want to solve this, we now say solution. Solution. We said we are going to apply. If you apply sine rule here, we know side A. We don't know angle A, but we know side B and angle B. Just say A all over B sine A. That's sine rule. It's equal to B all over sine B. At least out of the 4, we know 3. We can actually get the remaining one. A is given as 7.82 all over sine A. That's what we are looking for. Angle A is equal to B is given as 14.35 all over sine 115.6 degrees. Please look at when I introduced quadrants the other time. I said sine 115.6 falls under the second quadrant, and in the second quadrant, sine is positive. So that simply means that sine 115 degrees is same thing as you saying sine 180 minus 115.6 degree. So that's going to give us around 64.6. So what we're trying to say is that sine 115.6 degrees is same thing as sine 64. The same thing as sine 64.4 degrees is the same thing, because we can't get this 115.6 in the calculator in the fourth figure table. We can actually get it in the inside the calculator. So just know that this is the same thing. Then if I cross multiply here, so I can use this interchangeably. So if I cross multiply, I'm going to have 14.35 sine A to be equal to 7.82 sine 64.4 degrees. That's what I'm trying to say. That I can actually do that. Then if I divide both sides by 14.35, I divide this by 14.35. This will cancel this. I'm going to have sine A. So I'll be left with sine A. Then sine A can actually give me sine A. Now sine A will now be equal to 7.82. If you check sine 64.4 in your calculator, you are going to have it to be 0.9018. Or if you press your calculator, just press sine 115.6 directly. But you are rest assured that sine of angle greater than 90, between 90 and 180, is actually positive because of the quadrant that we have discussed the other time. That's 14.35. So if you multiply this, and divide by this, we are going to get sine A to be equal to, sine A will be equal to 0.4914. Then how do we find A? A will now be equal to arc sine. Second, from a calculator, you can just press shift the sign of this 0.4914. Then if you do that, A will be equal to 29.43 degrees. That's what we're going to get. Then A is approximately 29.4 degrees. That's the value of A. We are asked to find the value of A and C. So we have gotten the value of A. So how do we get the value of C? Since there are 3 angles in a triangle, we are given one, we'll be able to find one, then we go ahead and use sum of angle in a triangle to be able to get C. Or if you don't want to do that, we can also apply sine rule again. To be able to get the third angle, we can apply sine rule again. Just say B all over sine B is equal to C all over sine C. Okay? So if you want to solve completely, but in this case now we are just asked to calculate A and C. So to be able to get C, we just say angle A plus angle B plus angle C. Angle A plus B plus C is equal to 180 degrees. Reason, sum of angles in a triangle. Okay, we know angle A to be 29.4 degrees. We know angle B to be 115.6. Then plus angle C is equal to 180 degrees. So if you add these two together, here will be 0. Is remainder 1, 4. Here will be 5, 145 degrees plus angle C is equal to 180 degrees. So angle C will now be 180 degrees minus 145 degrees, and that's going to give us 35. That will give us 35 degrees, and that's angle C. So we have been able to find angle A to be 29.4 degrees, and B and C to be what? 35 degrees. So that's how to apply sine rule. Then at times you'll be given just one side. You'll be given one side and two angles. So and you'll be asked to find the other one. So let's take another example. Let's take example 2. Example 2. So it is possible to also have your question in this form. Example 2, where we have in triangle ABC, we are given angle A to be 29 degrees. Then we are given angle B to be 36 degrees. And side B to be 15.8 meters. The question now says, find A. That is, we should find angle A. Then solve the triangle. Solve the triangle completely. Solve the triangle completely simply means we should find all the three sides and all the three angles in the triangle. Okay, solution. So let's just sketch the triangle. If you are given a triangle, just try and sketch that triangle. Say this is A, B, C. So the side that faces here, A will be, we don't know. This is B, and it's given as 15.8 meters. Then this is small c, we don't know. We are given angle A to be 29, angle B to be what? 36. So we are, the first question says that we should find A. We are looking for side A. Then the question says further that we solve the triangle completely. That is, even if we know this side A, we should also go ahead and find side C and angle C. So let me first find side A. That's the first question. I said we don't know. Of course, I can get side C without any calculation. Just add all these three angles together and say it's one, it's sum of angle in a triangle. C will come out naturally. Then we go ahead and find side C. So from there now we say using sine rule. You say A all over sine A is equal to B all over sine B. Okay, what is A? That's the unknown. All over sine A is sine 29 degrees. It's equal to B 15.8 all over sine 36 degrees. That's what you are going to get. That's what you are going to get. This same thing as then if you cross multiply, we have A to be equal to 15.8 sine 29 degrees all over sine 36 degrees. So that's what you are going to get. So what is sine 29 degrees? So here we have 15.8 times is 0. Sine 29 degrees is 0.4848. All over sine 36 degrees is 0.5878. That's what you're going to get. And what is the value of A? A, side A, will now be equal to, if you multiply that, this is 15.8. This is 15.8. So if you multiply that, let's multiply 15.8 times 0.4848 divided by 0.5878. If you do that, you're going to get A to be 13.03 meters. So A is approximately 13 meters to the nearest whole number. That's what you're going to get. A is 13 meters. So we have been able to find A. But the question says we should solve the triangle completely. That is, we should find C, side C, and angle C. And of course, I can get angle C. So I'll just say angle A plus angle B plus angle C. All these three angles is equal to 180. We are given 2, so we can find 1 without any calculation. Sum of angles in a triangle. Then A is 20, angle A is 29 plus 36 plus C is equal to 180. If I add these two together, that would be 65 plus C is equal to 180 degrees. So C is equal to 180 degrees minus 65 degrees. So angle C is equal to 115 degrees. So since I know angle C now, so I can either use sine A over A is equal to C over C, or B all over sine B equal to C all over sine C. Whichever way I decide to apply, we are still going to get the same answer. So we have gotten the value of A, we have gotten the value of side A, we have gotten the value of angle C. We are required to find the side C, the small c now. So I'll just continue. I say use the sine rule. I'm going to clean this place. I equate it to C. So I'll say this is equal to C all over sine C. So it's still the same thing because in the general formula, A over sine A is equal to B over sine B equal to C over sine C. So I can try to equate any two. So what is A? We've gotten here to be 13.03 all over sine 29 is equal to C. We are looking for all over sine 115. Please look at sine 115 is the same thing as sine 65. If you press your calculator, it's the same thing. You can't get this from fourth grade table. So if you are given this and you want to check your fourth grade table, you subtract this from 180 because sine is positive in the second quadrant. So if I cross multiply here, I'm going to have C to be equal to 13.03 sine 65. I decided to change sine 115 to sine 65. And you know the reason. Sine is positive in the second quadrant. The second quadrant is 180 minus theta. So all over sine 29 degrees. So if we do that, then we are going to get, from there, we are going to get C to be equal to 13.03 multiplied by, what is sine 65? Or sine 115? It will be 0.9063 divided by sine 29 is 0.4848. So C will now be equal to 24.4 meters. If you check, you use your calculator and get the answer. So we have been able to solve completely. We are given two angles on one side. So we have been able to find the two sides and the remaining angle. And that is what we are asked to do. And that's what we have done. So under sine rule, we should note under sine rule that we must know the condition to use sine rule. We must know the condition to use cosine rule. So under sine rule now, the conditions to use sine rule simply means that we use sine rule to solve triangle in which either two angles and any side are given. That is, under sine rule, we must have two angles and any side are given, and side are given, or when you have two sides and the angle opposite one of them. So these are the two conditions to apply sine rule. I will want to stop here because of our time. In our next class, we are going to introduce cosine rule, and we'll check the conditions to be able to find cosine rule. Then, so once we are able to find cosine rule, then I can introduce what is called bearing, because the vast knowledge of sine rule and cosine rule will actually help us to be able to solve problems under bearing. So in our next class, I'm going to introduce cosine rule. Then after cosine rule, I have video on SOHCAHTOA, Pythagoras theorem. Then I can conveniently introduce the concept called bearing. So we use the knowledge of sine rule and cosine rule, SOHCAHTOA and the rest to be able to solve problem under bearing and distance. Thank you, and God bless you all.
Mathematics made easy, no more fear. Target online class, we got you.